So in the last class, we were discussing about what? We were discussing about Kmap. I told you how to minimize using Kmap. So this was one question. Here you can see this phi. This corresponds to don't care. So don't care, we always use it for groupings. Okay, we use it for groupings. So grouping means what? For increasing the size of group. Now suppose if here it is asked what? The minimal product of some function described by the Kmap. Okay, I have started the recording. So function described by the Kmap given in figure is. So you need to find what? Product of sum. And I told you whenever we do product of sum, we make group of zeros. So if suppose you make groupings like this is one group of 0, this is another group of 0. And if you write the max term corresponding to the groups, so this will be what? A complement plus B, and for this one it will be C complement plus A. So your F will be what? It will be A complement plus B, C complement plus A. So you can see none of the options will match. Okay, it will not match. You need to solve this once again. Like if you solve this will be A complement C complement plus A complement into A, that is 0. Then this will be what? B C complement plus AB. Okay. Now you can see one thing. If I rearrange this will be what? AB BC complement plus A complement C complement. So here the terms are in cyclic order AB, BC, CA. So I can apply what? Consensus law. So if I apply consensus law, you can see B is in non-complemented form everywhere. A is in complemented, non-complemented form. Okay. So I need to retain this two term using consensus law. So that will be AB plus A complement C complement. Okay. So once again I can solve this. I can solve this like so what we can do. So okay, I will not be doing this because this will create problem. It's okay. So you can still see that I am not getting the minimized expression. Okay. Now if I want to get minimized expression from this, I need to expand it once again and it will consume time. So what we do basically, we can use this don't care conditions for increasing the size of group. Increasing size of group. So that means what? See, I told you what? Don't care condition means what? Either it will be 0 or 1. We don't know. We don't know what will be the state. Okay, it can be either 0 or it can be 1. But that doesn't mean we are going to make an individual group for this don't care. No. Don't care, we are not going to make individual group. We are only going to use don't care for increasing the group size. So previously we were making a group like this and this. Now if I take this don't care into consideration, what I can do, I can increase the group size from a group of 2 zeros to a group of 4 zeros like this, and one more group I can make. Previously it was like this, it was a group of 2 zeros. Now I can make it a group of 4 zeros. So now corresponding to this, my product of sum or your max term will be what? You can see only C equal to 1 is common, so that is C complement. This is product of sum, so this is the sum term. The sum term for this one, it will be what? You can see in this two column, A equal to 1 is common, so this will be A complement. So this comes out to be A complement, C complement. Option A is correct. Okay, option A is correct. Now suppose if they had asked a question, calculate the sum of product. So for sum of product, what we would have done, we would have grouped the ones We would have done what? We would have grouped the ones. So if I want to group one, so you can see the only possible way is this. Now don't have this confusion that I told you don't care can be either 0 or 1. So you might be thinking, okay, sir told us don't care can be anything, it can be 0 or 1. So let us assume this as 1 and let us make one more group like this. This is very wrong. You never make separate group for don't care. If there is a possibility that using the don't care, you can make a group that is actually that has size more than the group without don't care, then you can make it. If there is no possibility of increasing the group size by increasing don't care, you are never going to make a separate group for don't care. So if I write the minterm for this group, this is what c equal to 0 is common, so c complement, and over here a equal to 0 is common, so that is a complement. So if I write the minterm, so that is a complement c complement, you can see the SOP, the POS is same as the SOP. So I have already told you SOP and POS they are basically the same way of representing a Boolean function. Okay. Now let us go to this question. So tell me what will be the answer very quickly. So Shubham, did you understand where you were making mistake?
Yes, sir. Yes, sir.
Okay. So now solve this question everyone quickly. After that I need to discuss implicant, prime implicant, essential prime implicant. So what is the question over here? The number of product terms. So what do we mean by product term? In the minimized sum of product. Okay, so they have actually written minimized sum. So they have already told. So that means product term means what? Min terms. I have already told you. And sum terms mean what? It means max terms. So the number of product terms in the minimized sum of product expression obtained through the following Kmap, where D denotes don't care states. Okay, so D denotes don't care states. So you need to find the SOP for this one. So one of the groups I can see, I can make of this corner ones a group of 4. Okay, one more group I can make, so that will be like this. Okay, any other group that I need to make? No. So you can see for this one I will get one minterm, and for this group I will get another minterm, so in total 2. So option A is correct. Why nobody could solve? This is very simple. And if I wanted to write your SOP expression, let me assume this is A, B, C, D. So you can see for this one, this green color group, it will be what? B equal to 0 is common, so B complement, and in column what is common? So C D equal to 0, so B D complement, plus for this one you can see A, and over here it is C D complement. Very simple. Okay, so why we couldn't solve? This is a very simple question. Now the next very important topic is what? What is prime implicant and essential prime implicant? How many of you have this very basic idea of what is implicant, prime implicant, essential prime implicant? You can let me know so that I will know that what is your depth in this knowledge, means in this topic. Anyone have any idea what is implicant, essential prime implicant? It's okay. So I am assuming that you people you don't know. Okay. So I am assuming this. Okay. So now what do we mean by prime implicant, essential prime implicant? So let me assume I have a function, a 4 variable function a, b, c, d, which has minterms like this. Okay. So if I fill the cell, so in 2 I have 2, 3, 7, 8, 10, 2, 3, 7, 8, 10, 12, 13, 15. So 12, 13, 15. Okay, 12, 13, 15. It's 2, 3, 7, 8, 10, 12, 13, 15. Okay, fine. So, wait a second. So 2, 3. Now this will be easier for you to understand. Okay. Now look, what is implicants? Okay, implicant. Suppose I give you few functions like g1. Now look here, this is the function. Now this g1, I gave you one more function. So you can see what this f is, what it has variable a, b, c, d. Even this g1 has variable a, b, c, d. Okay, even g2, g3. Now you can see whatever is the minterm of g1, all the minterms are present in f. So this g1 is basically an implicant of f. Okay, or you can say a subgroup. Implicant means what? A subgroup of f. Similarly, if you check g2, so it is what? 7, 10, 12, 13, 15, 7, 10, 12, 13, 15. So again this one, you can see what? This is basically a subgroup or an implicant of f. Now check g3. If you check g3, this one is not present in this function. So this is not implicant of this function. Shruti, you have some doubt? You can ask. So basically with implicant means that basically they are sub-function of a given function. Okay. Like your g1, g2 for example are implicant of this function as f, whereas this g3 is not implicant of this function. So anybody want to ask something, or else I will erase this part and I will start explaining what is prime implicant and essential prime implicants. So write the definition of implicant. Implicants are basically the sub-functions of a given function. Sub-function of a given function. Now let us focus on prime implicant. What is prime implicant? So prime implicant, let us first see using this question that I have taken. Okay. So see very carefully. What are the possible groups that I can make? See, one of the group I can make like this. Okay. One of the group I have made like this. One another group I can make like this. Another I can make like this. One more like this. And one more like this. But if you see this group, look at this group. Can I increase the size of this group by any means possible? This is a group of 2. I cannot increase its size. So this is one prime implicant. Look at this. So this 3, let me write G1, which is min term 2, 3. This is one prime implicant. Then look at this group, this 10, 8 and 10. This is 8, this is 10. Okay, 8, 10. Can I increase the size of this group? I cannot increase the size of this group. So this is also what? This is one prime implicant. Look at 8, 12. If you look at this group, this is also, I cannot increase its size any way possible. So this is also prime implicant. But now let me ask you, if this group is this prime implicant? Up to this point, all of them are prime implicant. Okay, all of them are prime implicant. But this G4, G5, it is not prime implicant. Why? Here I have made one implicant. This G4, G5, they are basically implicant of this F, but it is not prime implicant. Why? Because this two group can combine to form a group of 4. So this is not prime implicant. Okay, these are not prime implicant. Okay, so prime implicant will be what? Let me assume one more function G6 that has min term number 5, 7, 13, 15. So this is your prime implicant. Now see very, very carefully. Let me ask you, if this min term number, is this prime implicant? Is this prime implicant? G7 and G8, right? Yes or no? G7 and G8. See, G7 means what? G7 means this group. Okay, this group. And G8 means what? This group. Is this prime implicant? Yes. These are prime implicants. Why? Because I can make a group of 2 ones like this. So this is prime implicant. This is prime implicant. Now you might argue that, sir, these groups are not required. It's okay. It's not required for minimizing, but still I can make a group of ones like this, a group of ones like this one and like this one. So this is also prime implicant. So prime implicant are basically what? It is the best possible grouping irrespective of the requirement. So what did I say? Prime implicant, it is the best possible grouping irrespective of requirement. Okay. Now you might even argue, sir, why can't we make one more group like this one? Okay. Yes, you can definitely make a group like this. Okay. You can definitely make a group like this also. It's up to you. Whichever way you want. Either you can make a group with this one, or you can make a group with this one. So this is also prime implicant. Even this is also prime implicant, like 2 and 10. So G8 is what? 2 and 10. This is also prime implicant. So what did I say? Prime implicant are all the best, are all the best possible groupings irrespective of the requirement. Okay, so they are what? Basically all the best possible grouping irrespective of the requirement. Is this clear? Is this clear? Now let me ask you what is, means let me show you what is essential prime implicant. So very quickly let me draw the Kmap. So don't do this in the same diagram. This is already hodgepodge over here. Okay, so make one more Kmap. So 2, 3, 5, 7, 8, 10, 12, 30. Okay, so 12, 13 and 15. Now let me tell you what is essential prime implicants. Okay, essential prime implicant. Now search for those ones. Okay, how do you search for essential prime implicants? You search for those ones which have only one option to group. Okay, you search for those ones which have only one option to group. So if you look carefully, so look at this one. This one. Let me use some different color. Look at this one. This one has only option to make a group of 4, something like this. It has no other option. It has no other option. Like this one, it can make a group of 2 like this. Okay, it can make a group of 2 like this. Or even this one, it can make a group of 2 like this, or it can even make a group of 2 like this. But this one, means sorry, group of 2 I am telling, group of 2, I am very sorry. So here the best possible group for this is what? It is 4. Now look for this one. This one, it cannot combine with other ones to make a group of 4. It cannot combine. Even this one, it cannot combine with adjacent ones to make a group of 4. Even this one, it cannot combine to make group of 4. So what is the best possible group over here? That I combine it like this. Okay, I combine it like this. Now, what other ones have only one possible option for grouping? Tell me. Tell me which one? Which other options do you think? Anyone? 5, 15 you are telling. So 5 is over here, and where is 50? Where? How can 5 and 15 be, means these cannot be grouped. Okay. So now look, this one has only one option. What is that option? Either it can connect with this one, means it has two options basically. Either it can group with this one, or it can group with this one. So this is also not essential prime implicant. Okay, this one is also not, it will not be essential prime implicant. Look for this one. So this can make group with this one, or it can make a group with this one. So this is also not essential prime implicant, this one. Now check for this one. So this one, either it can group like this, or even it can group like this. So this is also not essential prime implicant. What about this one? This one, it can either group like this, or it can group like this also. So this is also not essential prime implicant. So the essential prime implicant over here is this one. Okay, only this. Okay, this is the only essential prime implicant group. So maybe I should take one more example. Okay, let me take one more example so that you can understand more clearly now, because this here only one essential prime implicant you were able to see, because that was a random example. So let me frame one more. Yeah, now this is correct. So tell me, how many essential prime implicants can you see? Essential prime implicants. How many essential prime implicants can you see? So let me write the numbers also: 0, 1, 3, 2, 4, 5, 7, 6. Look here very carefully. If you are not, and if you haven't understood, so you can look here. See, once again you can see this one. This one, it has no other option to combine. It has only one option, that it can combine with this group of 4, okay, to make a group of 4. Okay, so this is one essential prime implicant. Now look at this one. This one, it can either combine like this, or it can combine like this. So this is not essential prime implicant. Okay, this is not essential prime implicant due to this one. Now look for this one. This one, this one, it can combine like this, or it can combine like this. So this is also not essential prime implicant due to this one. Now check for this one. If you see, it has only one option to combine like this. So this is another essential prime implicant you have. Now look at this one. This also has only one option to combine, that is like this. So previously I told you what, that when I was checking for this one, okay, this one, I told this has one option like combining like this, or it has one option combining like this. So this, due to this one, this grouping was not essential prime implicant. But the moment I go and check for this one, you can see now this one has only one option to group, and it is like this. So this grouping is now essential prime implicant due to this one and not due to this one. Okay, not due to this one. It is essential prime implicant due to this one. So how many essential prime implicant we got? We got 3 essential prime implicant. So did we understand? So essential prime implicants are those implicants which have only one options for grouping. So what did I say? Essential prime implicants are those prime implicants which have only one option to group. Okay, understood? Any doubts, anyone? Okay, fine. So now solve this question and tell me what is the answer very quickly. And if you have any doubts, you can ask me. So I have lot of questions of prime implicant, essential prime implicants. Very quickly tell me. What are we getting answers? So here essential prime implicants are asked to us. Okay. So look very carefully. Okay. Essential prime implicants are those prime implicants which have only one option to group. So what I told you, you check one by one. So this one, you can see it has only one possible option to group, that is what? To make a group of 4 like this. Okay. Does it have any other option to group? No, it doesn't have any other option. Even this one, so this one has only one possible option to group like this. Okay. This one, this has two options. Either it can combine with this group of 4 or it can combine like this. So this one is not essential prime implicant. Due to this one, listen very carefully what statement I am making. Due to this one, this group of 4, let me denote it by G1. Due to this one, this G1 is not prime implicant. It is prime implicant due to this one and even this one, because this one has no other option to group. So due to this 3-1, this G1 is prime implicant. Okay. So this is one group for which you have prime implicant. Now see, this one, how many options does it have to group? So this one has only one option to group like this. It has no other option. So this is group 2. So this is also one more essential prime implicant. Now look at this one. This one has only one option to group like this. So this group is another essential prime implicant due to this one. Now look at this one. This one has option, either it will group with this one or it will group with this one. So due to this one, there is no essential prime implicant. Now check the last one, this one. So this one has only one option to group like this. So this is also essential prime implicant. So group 4. So how many groups you have in total? 1, 2, 3, 4. So 4 is your answer. Yes, very good. So Shruti, first you wrote 3, then you wrote 4, and again means 4. So that is okay. So others, did we understand? Did we understand? Any doubts? Okay, fine. Solve the next question. So here they have asked prime implicant, and that too in min term form. So they are asking what are the prime implicants over here. So prime implicants are those implicants, basically all those groupings which are irrespective of the requirement, we form a group. Okay, irrespective of the requirement. A. So look very carefully. B was for last question. Okay, okay. Sorry. So if you see over here, so prime implicants are asked. Okay, prime implicant. So prime implicant, this is one group you can make. This is another group you can make. So this group, if you write, so this will be X and Y complement, and for this one it is X complement, and over here Y. So which option do we see? X Y complement, X complement Y, option A. If I ask you what are the essential prime implicants, so essential prime implicants, it will be also the same. Okay, essential prime implicants will be also these two. So here you can see the prime implicants are equal to the essential prime implicants. Okay, in this question. Now this question, what do you think will be the answer? Tell me very quickly. So understanding prime implicant and essential prime implicant, it is very difficult. It took me lot of time to understand what do we mean by essential prime implicants and prime implicants. So when I was preparing, I was not able to get a proper answer for questions that what do we mean by prime implicants and essential prime implicants. So what are the minterm numbers given? 0, 2, 4, 5, 6. 0, 2, 4, 5, 6 and 10. Okay, so the total number of prime implicants are asked over here. Okay, prime implicants. So I am not able to get for which one you are telling 5 and 4. For this question, so here prime implicants are asked, not essential prime implicants. Okay. So look very carefully. Prime implicants. So prime implicants are basically all the groups irrespective of the requirement. So you can see I can make a group of 4. I can make a group of 4 like this. Then I can make a group of 2 like this. Okay. Then one more group of 2 I can make like this. Okay. So in total there is 3 prime implicants. Okay. 3 prime implicant. So what is the answer? You people are getting 3. Bhumika got others. Okay, fine. So 3 is the correct answer. Okay, 3 is the correct answer for this question. Now solve this question. Very good, Shubham. Solve this question. So this is a good question. So look here very carefully. Look here very carefully. I couldn't understand how it is 3. So why you couldn't understand how it is 3? See, here it is asked prime implicants. Prime implicants. So prime implicants are the best possible group without any requirement. Okay, best possible group. See, now if you had made, you should have told me earlier, now even I couldn't erase this. So look here. See, it is the best possible group. What? I didn't say anything and you understood. So that is good. So okay, if you understood, then it's okay. Then let us solve this question. So it's okay. So look over here. They have given you minterms. Now how to quickly fill them? So what is given? The first minterm is wy. So that means what? W equal to 1, y equal to 1. So search for the places where w is equal to 1. So w is equal to 1 is in this two place and y is equal to 1. Y is equal to 1 is available in these two places. So that means all these places you are going to fill with 1. Next, see what it is, xy. So x1, y1. So where can you see x equal to 1 and y equal to 1? In this two place, x is 1 and y is 1 in your this two places. Okay, this two places. So that means once again you need to fill the common places. So this is the place and this is the place. Already these two are filled. Next is what? W complement x, y, z. Okay, W complement. So this is 7. This is 7. So 7 comes over here. 0, 1, 2, 3, 4, 5, 7, 6. So this is already filled. Next is what? W complement x complement y. So W complement means this is 0. Sorry. Yeah, this is 0. This is also 0. And this is y. Sorry. So this is y. So this is 1. Okay. So check where w and x are 0, 0. So in this row w and x are 0, 0. Y is 1. Where? In this two column y is 1. So that means this 2 1 needs to be filled. Next is what? xz. So x equal to 1, z equal to 1. So x equal to 1 is in this two place and z equal to 1 is in this two places. Okay, so the common is what? This one and this one. Now last is what? X equal to 0, y equal to 0 and z equal to 0. So x 0, y 0, z 0. So x is 0 in this one and this one. And where is yz 0? So yz is 0 over in this whole column, yz is 0. So the common places are this one and this one. So you have filled the box. Now as I was explaining, so I did all this, or else I could have filled it directly also. Now if you are comfortable like this, you can do it, or else what you can do, you just fill the cell numbers. So this is 7, 8, 9, 10, 11, 12, 13, 15, 14. Then you could do what? First is wy. So you know what? This is wxyz. So w is 1. Then here you have to put cross, then 1, then again cross. So if you put 0, 0, so the first will be what? It will be 6. So 6 is over here. Then if you put 0, 1, so that will be 7 over here. Then if you put 1, 0, so that will be 12. Sorry, that will be 8 plus 4, 12, 14. So 14 will be over here. And if you put 1, 1 over here, so that will be 15. So you can see 15 is also filled. Like this, you can fill the cells. Okay. So now tell me, what is the set of essential prime implicants over here? What is the set of essential prime implicants over here? Three. Means option, tell me. Options. What is the option that you are getting? So here the question is in option A, B, C, D. So which option are you getting, Shubham? D. Okay, let us check. So the very first one, if you check this one, so this one, if I make a group of 8, then what? I am covering all the ones. So due to this one, this group is what? This is essential prime, sorry, not due to this one, because this one has one more option. What is that? It can group with this one also. So due to this one, this is not essential prime implicant. You can even check for this one. This one has only one option. That is what? That is, it needs to group with all the remaining ones over here. So due to this one, or even this one, and not this one, even this one, not this one also. So due to 1, 2, 3, 4, 5, this 5 ones, this group is an essential prime implicant. So let me write it as group 1. Now next, what can you see? This one, it has only one option to group with this. So this is one, sorry, I should be using some different color. So this one, it will make a group of 4 like this. So due to this one, this all 4s are what? This is one essential prime implicant. Now check for this 2, 1. So this has only one option. This one has only one option. Even this one, it will only group with this. So now if I want to write the min terms, so this has what? Over here you can see only y is equal to 1 is common. For this group, you can see x equal to 1 is common, and over here z is equal to 1 is common, and in this group of 4, what is common? So you can see x equal to 0 is common, and in column what is common? Z is equal to 0. So Z complement. Option D is your correct answer. Okay, option D is your correct answer. Very good, all of you. Now let me ask you one more question, last question. So this will be your homework. Okay. So you need to find what? You need to find prime implicant as well as essential prime implicant. Prime implicant and essential prime implicant. Yeah, this is okay. So you will be finding prime implicant and essential prime implicant. So quickly note this down. Noted? Okay, fine. So now next we have is what? Boolean arithmetic. So in Boolean arithmetic, first thing we are going to study is what? Ones complement. Okay. I don't know why I am not feeling well today. So we will see ones complement, twos complement, and if I feel okay, I will continue with it, or else I will leave you. I don't know. I am having severe headache now. So look here, ones complement. So we are starting what? Boolean arithmetic. So what do we mean by ones complement? Suppose we know what? How to calculate the binary equivalent of a decimal number. So we do what? We do repeated division by 2. So 2 divided by 10 is what? 20. Remainder is 1. 2 divided means 2 into 5 is 10. So 2 divided by 10 is 5. Remainder is 0. 5 sorry, what I am telling you now means I am 5 divided by 2 is what? 5 divided by 2 is quotient is 2, remainder is 1. So 2 divided by 2 is what? Quotient is 1, remainder is 0. So this is how we convert, okay? And this position is what? This is your MSB and this is your LSB. So we start writing like this. So 21 is equal to what? It is equal to 10101, or even you can write it like this, 16 plus 4 plus 1. So 16 means what? 2 to the power 4, 2 to the power 2, 2 to the power 0. Any number you can break it in the power of 2's. Okay, you can break it in the power of 2. So then you can even write it 2 to the power 4 means what? There should be 5 bit. So the fifth bit should be 1. Then your third bit, it should be what? It should be 1. And your last bit should be 1. So you can even write it like this. Whichever way you are comfortable, you can write it like this. Now ones complement, if you have studied, so basically it is said, suppose if I want to calculate ones complement of 21, whose binary equivalent is what? 10101. So if I want to calculate ones complement, what we do? Bit by bit we complement. So 1 will convert to 0, 0 will convert to 1, 1 will convert to 0, 0 will convert to 1, 1 will again convert to 0. So this is the ones complement of this 21. But do we know why do we complement this bit by bit? Why do we complement it bit by bit? Can anyone tell me the reason for that? Why do we complement? Means you people might have studied this. Anyone from computer science, ECE, electrical? Anyone want to say? You can speak up also. It's okay. No need for typing. Just unmute yourself and type. And say. Anyone? So quickly, Piyush, we don't have that much time. Adding ones to one complement will give the means I am not what adding ones to ones adding 1 to 1's complement will give the original binary number back. So that means if I add 1, so it will give my binary number back. So this is what you meant, Piyush? Yes, you are incorrect. So look very carefully. Basically, one's complement means what? That this number, this is 1, 2, 3, 4, 5, 5-bit number. What is the maximum number of 5-bit number possible in binary? Maximum 5-bit number, it will be 11111. So from this 11111, I subtract this number 10101 to get the ones complement. So that is what? 1 minus 1 is 0, 1 minus 0 is 1, 1 minus 1 is 0, 1 minus 0 is 1, 1 minus 0 is 0. You can see this is the ones complement. So basically whatever is the number given, we actually subtract it from the highest number of the given number, means of the given bit, okay, of the given bit. Like suppose if I have 16, so 16 is what? 16, I can write it like this. So if I want to write ones complement in shortcut way, what we know, everyone knows that bit by bit you need to complement. So this will be 0 1 1 1. Now if someone asks you how do you get, what is the reason that we complement bit by bit, you should be able to say that using 4 bit, the highest number is this number. So if I subtract this number, so this is not 16, I am very sorry. Okay, this is 8. Okay, this is 8 and this is 15. I am really very sorry. So this is 8. So I have calculated the ones complement of 8. So this will be what? 1 0 0. So subtract this. So this will be 1 1 1 0. You can see you are getting the ones complement of the number. So basically ones complement of the number means what? That you are subtracting it from the maximum number of the bits that are possible. Okay, is that clear? So this is what I meant by ones complement. Now there is one more thing known as twos complement. Now why do we use twos complement or ones complement? We will see that. Okay, we will see that. Now what is this twos complement? So just now we saw what? 21 is what? 21 is 1 0 1 0 1. Now what do we mean by twos complement? What do we mean by twos complement? So will you say, sir, twos complement means 2 2 2 2 2, and then we are going to subtract it like this and say, sir, this will be 1 2 1 2 and 1. But this is invalid. This is not binary number, because in binary we don't have 2, we have only 0 and 1. So how will 2 come? So this is not twos complement. So for twos complement of a number, what we do? So basically what we do, we calculate first ones complement, and to that we add 1. So Piyush, that is twos complement, what you told me, not what you said adding ones to ones complement will give the original binary number back. So that is wrong. So now if I want to calculate the twos complement, so basically this is binary equivalent of 21. So if I want to calculate twos complement, so first what you need to do, you need to calculate ones complement. So ones complement will be equal to 0 1 0 1 0. Now to this add 1. So if you add 1, this will be 1 1 0 1 0. So this is what? This is your twos complement. Okay, twos complement. Is this clear? Is this clear? Is this clear? Okay, fine. Now again come back over here. Now if I tell you that this number is your ones complement, okay, this is your ones complement, find out the original number, find out the original number, find out the original decimal number. So what will you do? Very simple. You will do what? You will do again, once again, bit by bit complement. So that will be 1 0 1 0 1. So what you get? You get that this is 21. So for getting the original number, okay, so what you do? You take ones complement of the ones complement given number, okay, of the given number. For finding the original number, what you do? You take ones complement of the given ones complement number. Now same thing over here. If I told you that 0 1 0 1 1, this is the twos complement of a number, find out the original number. What will you do? First thing, calculate ones complement. So first if you calculate ones complement, this will be 1 0 1 0 0. Now to this add 1. So you will be getting 1 0 1 0 1. So again you can see this is 21. So we know 2's complement of 21 is this. So you can see you are getting the reverse number back. So original number, if you are given with 2's complement, so original number is given, means it is calculated by taking 2's complement of the given 2's complement number. Is this clear? Is this clear? Tell me. Is this clear? Any doubts, anyone? So everywhere I talked, I only talked about positive numbers. Suppose if I ask you, how will you represent minus 21 in binary? See, representing 21, 31, 2000, 500, any positive number, we know how to represent it in binary number, very simple. But now if I ask you how to represent negative number, because in computers also we enter negative number, even in calculator also, in every digital system we enter negative number. So how do we actually represent negative number in a digital sequence, in a digital system I should be saying, or precisely how do we represent negative number in your binary system? Adding extra 1 at MSB. Why? Why do we add extra 1 at MSB? Is there any logic? So tell me, what is minus 21 then? Minus 21, you are saying that, sir, please do this 101, sorry, yeah, 10101. So this is 21, and to this you add a 1 to your MSB position. So this is minus 21. Okay, fine. So now suppose if I give you this 110101. So decode this number for me. How will you know that this is minus 21? How will you know? How will you know? So that is why, means I am not pinpointing you, Shubham, or anyone. Okay, I am not pinpointing anyone. Okay. So during this preparation time, I will tell you this, that I am your biggest well-wisher. If someday I shout on you, if I scold you, it is for your own betterment. Because once I was in your stage also, my teacher, he was scolding me, he was shouting on me. That is why I am in this position today. Okay. So one thing I will say, if you know something, okay, if you know something, know everything about that topic. Okay. So it's not like I am telling you to study some rocket science. Okay, it's not like these are rocket science. If you know something, know completely about it. If you don't know something, know nothing about it. Okay. If you know something, then everything you should know. If you don't know something, then you should be knowing nothing about it. So if you add 1 over here, means you are saying something which is partially correct. Okay, partially correct. So I am not scolding you or pinpointing any one of you. It's okay. When I was at your stage, when I was preparing for the first time, I couldn't even solve properly KCL KVL. Okay, so that was my condition. So I will be saying in my BTech I got 7.49 DGPA. Okay, or you can say cumulative CGPA of all my 8 semesters. So that is not good. Okay, so I was not that bright student, but something changed in my life and I changed my focus completely to studying. Okay, so it's okay. Okay, so here I have talked about R's complement, R minus 1 and R's complement. Okay, fine. Okay, fine. So at the moment, I will keep this question unanswered, that how do we represent negative numbers? Okay, at the moment, I am keeping it unanswered. Now look, we have something known as R minus 1's complement and R's complement. So we have different number systems, like we have octal number, we have hexadecimal number, we have binary numbers, We have even decimal number. Okay, decimal numbering system. So in octal number, the base is 8. In hexadecimal, base is 16. In binary, base is 2. In decimal, the most versatile that we use, base is 10. So in your binary, r minus 1's complement is what? 2 minus 1, that is your 1's complement. Okay, and just now we saw how to calculate 1's complement. In octal number, r minus 1's complement will be what? 8 minus 1, so that is your 7's complement. Suppose you have a octal number, something like this, 1 2 3 4. Now I don't know what is this equivalent number in decimal. I am just telling that I have a octal number. So octal number will have digits from 0 to 7. So this is a valid octal number. So how do I calculate 7's complement? Simple. First write the maximum number that can be constructed using 4-bit and subtract this number. So you will be getting 3, 4, and this is 5, this is 6. So this is the 1's complement of the given number. This is what we were doing in 2's complement, means in 1's complement in binary. Similarly, if you want to calculate in hexadecimal, you can do that. Even in decimal, suppose if I have a decimal number 1 2 3. So here your r minus 1's complement will be what? 10 minus 1. So that will be 9's complement. So how do we calculate 9's complement? Very simple. 9 9 9 minus 1 2 3. So this will be 6 7 8. 8 7 6 is your 9's complement for 1 2 3. Okay, so this is r minus 1's complement. Now if you want to calculate r's complement, so r's complement, we have numbers again like octal, hexa, binary and decimal. So in binary we saw, if I want to calculate r's complement, so here base is 2, so basically that means 2's complement. So what we do, we take 1's complement plus 1. Now suppose if in octal number I want to calculate the 8's complement of the number 1 2 3 4. So first calculate 7's complement. So 7's complement of 1 2 3 4 is what? 7 7 7 7 1 2 3 4. Subtract it, so you will be getting 3 4 5 6. So this is 7's complement. To this add 1. So you will be getting what? You will be getting 4 4 5 6. So this is your 8's complement of 1 2 3 4. Similarly, in decimal number, we have 10's complement, that is r's complement. So this is 10's complement. So if I want to calculate 10's complement of 1 2 3, so once again I need to calculate 9's complement of 1 2 3 first. So that is 1 2 3. So this will be 6 7 8. To this add 1. So this will be 8 7 7. So this is the 2's complement number of 1 2 3. Is this clear, everyone? Whatever I just explained right now? Is this clear to everyone? Suppose, now let me tell you that there is some kind of number system which has base 5. Sorry, base 5. Okay, we have base 5. Now I have a number something like this, 3 4 1. So base 5 means what? It will have digits from 0 to 4. So 3 4 1 is a valid base 5 number. Now calculate me 5's complement. 5's complement. So what will you do? Calculate very quickly. (214) Shubham is saying. So very simple. First you need to calculate 4's complement. R minus 1's complement you need to do. So R minus here will be 4's complement. So that will be 4 4 4 minus 3 4 1. So that will be 3 0 1. Okay. that will be 103. Means I am so much now disoriented. Okay, so I am having tremendous headache. So this is what this is, 4's complement. Now to this add 1, so this will be 4, means 104. Means Shubham, how did you get 214? How did you get 214? How many of you got 104? I said 5's complement. Anyone got this number 104? Anyone? Me, very good. I got. Okay, good, good. Piyush, Shruti. Bhumika, what about you? You are least interacting with me. So you guys should be interacting, okay? So I will always say, you didn't get, why? You didn't understand or what? What happened? So okay, chalo, one more number. 4, okay, 432, okay, 432, chalo. Solve 5 complement for this number. 5's complement. It's okay, I will give you time now. Calculate very quickly. See, what I will suggest you guys, whenever you are studying, so if possible, study using laptop. Because when you study using laptop, you get the options to chat also, and you get, means you can also talk to me. But if you are using mobile, then make sure that you connect your mobile with a microphone so that even you can talk to me, okay? Because chatting, it is a little bit difficult. Okay, it's little bit difficult. So for 432, if yes, tell me Shubham, what happened?
Sir, I have a doubt. Please explain the question. Explain the question last.
What? Pardon?
I have a doubt, sir. So,
Uh,
so what I was saying, so in a 5 complement, you give like 432, okay, and here we have to subtract it from 444,
yes.
right? Yeah. So what happens if it's like the number is greater than 444, like 446, 448?
What 448 in 5 means in base 5 number? How will you get 448? This is invalid. This is
Yes.
invalid base 5 number. Yes.
Okay, sir. Got it. Yeah, got it.
Because you will have only characters, means digit from 0 to 4. You need
Okay,
to
sir.
represent a number using 0, 1, 2, 3, 4. So how will you get 8 over here?
Okay,
Okay.
sir.
Yeah. So if you now have to calculate 5's complement, so you need to subtract it from 444. So this will be 2, 1, 0. So now if you add 1 to this will be 0, 13. Now this doesn't mean you need to delete this 0. No, you are not going to delete this 0. Why? Because this is a 3-bit number that you have represented. See, 0, 0, 0, 0, this also corresponds to 0, and 0, this also corresponds to 0. Even 0, 0, this also corresponds to 0. But this is telling you what? This is telling you a 4-bit number. Now if you tell, suppose this is a very good thing. Now if you tell what? That okay, this is 0. So let me remove this 0 and write this number as 13. So now if I ask you, calculate the reverse number. So what you will do, this is 5's complement. So first you will calculate 4 complement of this number. So that is 4, 4, 13. So this will be what? So this will be 1, 5. Now to this you will add 1. So this number will become 2, 5. 52, it is coming 52. See, this is wrong. This is wrong. But if you take 0, 13, so what will you do? First you will be calculating 4's complement, so that will be 1. This will be 3. Means I have written 5 over here. I am very sorry. So this will be 3. So this will be 32. See, you are missing 4 over here. You are missing 4. Your original number was 432, but you are getting 32 when you remove this 0. So now you see over here, you will be getting again 4. If you add 1 to this, you will be getting the original number, that is 432. So don't ever remove this 0. Okay. Bhumika, did you get this answer? 0, 13, 0, 1, 3. I should be saying, not 0, 13. Good. Chalo, good. So now I will answer your question, how to represent negative number in binary. Okay. So look very carefully. We have for that signed binary numbers. Okay. Signed binary numbers. So first thing, in signed representation, when we represent positive and negative numbers, so this will be the last topic that I will be telling today, because I am not feeling not at all good. Okay, so I think this also I should be, it's okay, chalo, I will show you how to solve this, and later we will discuss. Okay, because I am feeling little means very much disoriented. Okay, so okay, so what I told you, how do we represent positive negative number in your, just a minute, yeah, so positive negative number in your binary numbers. So we have two kind of representation. One is sign magnitude representation, another is your complement form. Okay, complement form. Now in complement form also, in complement form we have what? We have two more classification. We can represent negative number using one's complement as well as using two's complement. Okay, using one's complement as well as two's complement. Just a minute. Okay. So now in sign magnitude representation, how do we represent positive and negative numbers? So 21 plus 21. How did we represent it? We represented it 1 0 1 0 1. Now in sign magnitude representation, we have one more bit and that represents your sign. So when the number is positive, your sign bit, actually it is the leftmost bit in your number. So if I tell you that in sign magnitude representation, how do you write 21 plus 21? So you will say 0 1 0 1 0 1, not 1 0 1 0 1. So in sign magnitude representation, plus 21, it is written like this, where this 0 represents your sign bit. Now if I want to write minus 21, so minus 21 will be written once again as 1 0 1 0 1. So this is the magnitude. Along with that, sign bit will be 1. Okay, sign bit will be 1. So remember this, in sign magnitude or even in complement form, the leftmost bit represent your sign. So this is in signed representation of number. Signed representation of one's complement, signed representation of two's complement, sign magnitude representation. In normal ones and two's complement, if they give you a normal sequence and ones and two's complement, this is not the case. Only in signed representation of one's complement and two's complement, leftmost bit represent the sign, where your 0 correspond to the positive number and 1 correspond to your negative number. Now, if you add positive and negative number, what will you get? You should be getting what? You should be getting negative number. So let us try to do 0 1 0, means this is plus 21, this is minus 21. Let us check if we get 0 or not. So this is 0 1 0 1 and this is 0 1. Along with the 1 we have over here, sorry, 0 we have over here for plus 21, and for minus 21 we have a 1 1 0 1 0 1. So add this 2, so this will be 0. Over here we have 1. Again if you add this, so this will be what? This will be 0, this will be 1, so you will be getting 1 over here. Sorry, have I made some mistake? So there is some bit mismatch, I guess. Wait a minute. 1 0 1 0 1. So 0 over here. 1 1 0 1 0 1. So this will be 1 plus 1 is 0. 1 over here. Again 1 plus 1 is 0. 1 over here. So this will be 1. 1 plus 1 is again 0. 1 over here. So 1 plus 1 is again 0. We have a carry 1. So now you can see with sign magnitude representation, when we add a positive number and its equal negative counterpart, I am not getting 0. Okay, I am not getting 0. So this is a very, very big problem while solving arithmetic equation. Okay, this is very, very big problem. So what we did, we switched to complement form. Okay, complemented form. So now look very carefully what we do in complemented form. So note this down. Now in the next page, I am going to show signed representation in this, the complement form. And first is what? Ones complement. Okay. So did you understand the problem over here? What was the problem? Did we understand the problem?
No,
Yes,
sir.
Shubham.
Will you explain again, sir, that you add that plus 21 and minus 21?
When you add plus 21 and minus 21, what should you get ideally?
0, sir.
0. But when I am doing this over here using sign magnitude representation, I am not getting 0.
Yes, sir, you're
So
getting
that
20.
is what I am getting. I don't know. This is not 0. I didn't calculate what is this. So this is a
Yes.
big problem. Okay, this is a big problem. Piyush, you have something to say? Yes, operation are erroneous in your SMR. Okay, sign magnitude representation, that I wanted to say. Now look in ones complement what we do. Suppose I want to represent 21 plus 21 in ones complement in signed representation. So this will be along with the sign bit like this. Now if I want to represent minus 21, so in ones complement the positive number, look very carefully, look very, very carefully. In ones complement representation, the positive number is same, it is same. Okay, plus 21 I have represented it the same way that I had represented the SMR. For positive number there is no change in ones complement, but the moment I want to write minus 21, what I will do, I will write 1 over here and the magnitude bit, it will be complemented 1 by 1. So this is minus 21 in ones complement. This is what? This is minus 21 in ones complement. So what I did, basically for negative number, if I wanted to calculate like minus 21. So if I wanted to calculate minus 21, so first calculate what is 21. So 21 is 10101. Okay. And to this, now first thing you need to do is add the sign bit because this is negative number. So start with 1 and the remaining magnitude bit you need to complement 1 by 1. Okay. So now this is what? This is minus 21 in ones complement, signed representation, signed representation. Now if you do plus 21 and minus 21, see what you get. And over here you get 0 1 0 1 0. So now add. So this will be 1, 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 and even you get 1. Okay, you get 1. Up to this point, is it clear? Tell me. Up to this point, is it clear? Is this clear? Now tell me, is this result correct? Is this result correct? Is this result correct? Yes or no? I am asking. Just take a guess. It's okay. Piyush, just tell yes or no. I just want to know yes, no. That's it. Bhumika, what do you think? Yes, okay. What about others? Shruti, what do you think? Yes, no? Okay, so you don't. Yes, okay, fine. So this result that we got, this is correct. Why? Look at the sign bit. So I have represented it using this color. Look at the sign bit. This is 1. This is coming out to be 1. So 1 means what? This is negative number. And if this is negative number, to the original number, to get the original number, you need to do what? You need to take 1's complement of the 1's complement number. Remember. So if you take 1's complement of this number, sign bit you will keep intact, keep it 1 only, and the remaining magnitude bit you complement. So this will be what? 0, 0, 0, 0, 0. And this is what? This is your minus 0 in 1's complement. We will see why this is minus 1 in minus 0 in 1's complement. But now we are getting the correct result. So whenever we have a negative number, we take what? We take your 1's complement. Tell me if this is clear or not. One more example I will show. It's okay. Now, let us do what? Let us subtract 21 minus 9. Okay? 21 minus 9. So what is this? We know that this is 12. Okay? This is 12. Let us see if we can get 12 from 1's complement sign magnitude, means sign 1's complement representation or not. So basically this is what? 21 plus minus 9. So 21, how will it be represented? It will be represented as 1, 0, 1, 0, 1. Now if I want to represent it in sign magnitude representation, this will be what? This will be 0, 1, 0, 1, 0, 1. If I want to represent it in your 1's complement, so in 1's complement, this will be represented as same 0, 1, 0, 1, 0, 1, because this is your positive number. So positive number sign magnitude representation is same as 1's complement representation. Okay. Now look, how do we represent 9? Okay, 9, how do we represent? So this is a very good example that I have taken randomly. So 9, how do we represent? Basically it is 1, 0, 1 in your binary. If I want to represent in sign magnitude representation, okay, minus 9, how will I write? Minus 9 will be represented as 1, 1, 0, 0, 1. In 1's complement, if I want to write minus 9, then what will I do? Keep the sign bit intact, remaining these are magnitude bit, so complement it bit by bit. So this will be 0, 1, 1, 0. So this is minus 9 in 1's complement. Okay, minus 9 in 1's complement. Now we need to add this two numbers. So this is what? 0, 1, 0 means, sorry, 1, 0, 1, 0, 1, and minus 9, how do we write? So this is 0, 1, 1, 0, and here we have the sign bit. What you can see, there is bit mismatch. There is bit mismatch. So what we can do? What we can do? Can anyone tell me what we can do? Add extra 0. Anyone else have any option? Any other means any other answer? See, whenever there is bit mismatch, never ever zero pad over here. Simply copy the sign bit. Copy the sign bit. Whatever is the sign bit, copy over here. So this will always remain 1. Okay. And always remember the leftmost bit is the sign bit. So now this has become the sign bit, not this one anymore. So automatically everything will be taken care of. Now see, if you add this 2, so this will be 1, 1. 1 plus 1 is what? 0. Carry is 1, 1. 1 plus 1 is 0. Carry is 1. 1 plus 1 is 0. Carry is 1. Now, tell me if we are getting the correct number or not. So this 1, 0, 1, 1. See, the leftmost bit is 0. The leftmost bit is 0. So this indicates basically this is a positive number because the leftmost bit is 0. So that is positive. But what is the number? See, these are all now magnitude bit. These are magnitude bit. So if you calculate, this is 8 plus 4. This we are getting 13. So we should have got, means, sorry, this is 8 plus 4 and 12. This is 13. Yes, 13 we are getting. So we are getting 13. We are not getting 12. So with 1's complement, whenever there is a carry generated, bring this carry over to LSB and add it. So this one, I will be adding it over here. So now if I write this, this will be what? 1 plus 1 is 0. This is 1 once again. So 1 plus 1, this is 0. Sorry, means what did I tell? This is 8 plus 2, 10, 10 plus 1, 11. This is 11 we are getting, not 13. I am very sorry, okay? This is 11, not 13. We are not getting 12. We should be getting 12 over here. So whenever in 1's complement, we have a carry generated, so that carry will be added. So now if you do this, this will be 0. This is 1, 0, 1. So this 1, 0. And this is your sign bit. This is your sign bit. So now this 0 indicates that this is positive number. For getting the original number, no need for taking complement. Simply you do what? You calculate the magnitude, you are getting 12. Did we understand this concept or not? Please tell me yes or no. Everybody? See, now one conclusion I will say. In 1's complement, this is specially for 1's complement, whenever carry is generated, this kind of carry out is generated. This is carry out, okay? Carry out. Whenever carry out is generated, this implies positive number. Carry out generated, it is positive number, and carry out is added to LSB. Remember this. No carry out generated, this implies negative number. This implies negative number. Okay. If carry out is not generated, it implies negative number. So note this down very quickly. After this, I am going to show you one more example, and after that I will end the session today. Okay, I will end the session here only. So now look, if I do minus 21 plus 9, so this time what I should be getting? I should be getting minus 12 as my answer. Okay, minus 12 as my answer. So let us see if we get, sorry, minus 12, yes, minus 12 only we should be getting. Okay, so do we get the answer or not? Okay, do we get the answer or not? So minus 21 plus 9, so that is minus 12. Do we get or not? So let us see. So 21, it is represented as what? It is represented as 101 in your normal binary. If I want to represent minus 21 in sign magnitude representation, now this time I am not going to use different colors. It will be 1, 1, 0, 1, 0, 1. If I want to represent this minus 21 in your ones complement sign magnitude representation, so this sign bit will be intact and the magnitude will be what? Magnitude bit will be complemented bit by bit. So this will be 0, 1, 0, 1, 0. So this is minus 21. Now plus 9, sorry, if I want to write 9, so that is 1, 0, 0, 1. If I want to write plus 9 in SMR, sign magnitude representation, so that will be 0. Sign bit is 0. 1, 0, 0, 1. If I want to write plus 9 in ones complement, so that will be also 0, 1, 0, 0, 1 in sign magnitude 1 complement. Okay. So now let us add this two. So this is 1, 0, 1, 0, 1, 0. Here you can see this is 1, 0, 0, 1, 0. So this is your sign bit. This is your sign bit. So now there is again bit mismatch. So what I will do, I will copy the sign bit. So again I copied the sign bit. Now add this two. So you will see 0 plus 1 is 1. 1 plus 0 is 1. 0, 0. So this will be 1 plus 1. You can see this will be 0. 1 over here. So this comes 1 and this is 1. You can see C out is not generated. So this implies this is a negative number. This is a negative number. And you can see even your sign bit is 1. Sign bit is 1. This is your sign bit. Now if you want to calculate the original number, you need to take complement of this number. So take complement. So this will be 0, 0, 1, 1, 0. So this is what? This is your 12. But as your sign bit is 1, so you need to put minus 12. So you got minus 12 as your answer. Tell me if this is clear to you or not. Is this clear? Is this clear, everyone? Okay, fine. So I will end the session today. Okay, I will end the session over here. Now let me tell you one thing. Now what was the problem in your ones complement that we had to switch to twos complement? Just think about it. I will write it over here also. Problem in ones complement that we mostly use twos complement. Okay. Mostly use twos complement. Can anyone tell me right now? Can anyone tell me? It's okay, fine. So I will only tell you guys. You think about this and let me know in the next class, okay? Is that clear?